The Deepwater Horizon accident reminded us that although we aim to minimize the occurrence of blowouts, accidents can still occur. As we continue to push the boundaries of exploration and production, we need to continually develop new safety technologies. Currently, a blowout preventer is the first line of defense, but if it fails, the next option can be weeks away from being deployed, potentially costing billions. Raptors Design Incorporated has developed the Hampering Active Wellbore Kit to generate a mechanical plug inside a failed BOP by feeding a wire into the free-flowing wellbore to create a tangled wire mass. The tool can also facilitate the introduction of well control fluids into the wellbore. The Hawk tool is designed for onshore as well as offshore operations. If the Hawk tool is always attached to a BOP's choke and kill port, it can be immediately activated if the BOP fails. Else, the Hawk can be deployed by an ROV to attach to the BOP, but this can take several days. Here on the left, you see an offshore oil rig with a blowout preventer on the sea floor. During a blowout where the BOP fails to fully close the well, the Hawk can be triggered to stem the flow. The Hawk tool creates the tangled wire mass by feeding wire into the wellbore where it buckles and generates an initial entanglement. As the wire mass grows, it gets carried upwards by the flow and pushed against existing restrictions like partially deployed rams in the BOP. Sealing is achieved as an ever-growing and denser tangled wire mass is compressed by the pressure differential, thus generating a dense tangled wire mass. The theory of tangled wire obstruction has been initially verified with experiments, including sealing under a back pressure of 2300 psi. In the fall of 2014, Raptors Design Incorporated was selected by the Repsol Foundation for a 2-year technology development program to design, fabricate, and lab test under full wellbore pressures the Hawk tool. The first milestone is to test the Hawk's wire feed unit at 1 atmosphere using a full-scale chamber that is equipped with a ram-like module to vary the configuration of the obstruction. The Hawk mates to the chamber via a 3-inch choke and kill port. The Hawk wire feed unit is powered in these tests with an electric motor and introduces the wire into the chamber. In the field, a hydraulic motor powered by a hot stop would be preferred. Here you see the Hawk feeding a wire into the chamber, which has a drill pipe in the center. Notice how the tangled wire mass builds around the drill pipe geometry. The next milestone will be to place the Hawk wire feed unit inside a drilling spool so it can be coupled to an actual BOP for testing under high pressure. Currently, we are obtaining the remaining components to run integrated tests with a BOP. Thus far, we have demonstrated the feasibility of the Hawk tool, and now, for this technology to be ready to deploy, we need regulators, operators, service contractors, insurance providers, and BOP manufacturers to work together now so we may all be ready for the future.